Hello everyone, and welcome to the section on linear regression. We will briefly look at the theory behind linear regression, and then we'll jump into Jupyter Notebook and see some live coding. As we have seen, regression is one of the most widely used statistical tools, and it's an example of supervised learning. So what's the idea behind linear regression? In linear regression, we have some set of features and we want to model how our observations that are associated with these features change as we change the values of the features. Let's see an example. Let's say we are trying to predict house values or house prices. We can say that a house has some sets of features like size of the house, how many bedrooms it has, number of bathrooms, lot size, and so on. The observation that we have is what's the price of the house, which is also known as target. In linear regression, we are given some input samples x and output samples y, and the outputs of this function is given by the outputs of the sample is given by the function y is equal to f of x. In this function, we would like to learn f and evaluate it on new data. In this case, y is a continuous variable, which is price of a house. Let's just consider the number of bedrooms as our features, which is x, and price as our target. So here we have a graph. On the x-axis we have number of bedrooms, which will represent our feature, and on the y-axis we have price, which is our target. Here we can consider the price in hundred thousands, and each of these blue points indicate data points or data sets, or specifically houses. So all these data points indicate houses in a given neighborhood. And as you see here, as the number of bedrooms increases, the price of the house seems to be higher. So again, in linear regression, we try to predict a target from the given features. Here we are trying to predict the price of a house given the number of bedrooms. We are only considering a single feature, which is number of bedrooms in this example. And if we look at this graph here, again on the x-axis, we have our feature, which is number of bedrooms, and on the y-axis is the price, which is our target or observation. And each of these red points indicate our data points or houses, and this black line indicates a linear regression fit line, and the blue lines indicate the distance or the difference between the actual price of the house and the predicted price. So the goal of a linear regression model is to minimize these errors, to minimize this distance as much as possible. So the best fit regression line, linear regression line, is the one with the lowest or minimal distance between the actual and the predicted price. So that's the goal of linear regression. Okay, let's talk about defining a cost for a given line. And one very common cost associated with a specific fit to the data is what is known as residual sum of squares or mean square error. In residual sum of squares or mean square errors, we take our fitted line and we look at each of our observations. In the previous example, the red points are observations and our fitted line is the black line. All these red points are observations and this is our fit line, the black line. So the goal of this residual sum of squares will be to minimize the distance between observation and our fit line. So here in residual sum of squares, we take our fitted line and we look at each of our observations. Then we look at how far the observation is from what the model would predict, which is just a point on the line. So we look at all of these distances here and we actually look at the square of the distances. That's why it's called the residual. The residual is the difference of your prediction and your actual observation. So we're looking at the same graph here. If you fit a line, if you fit this black line and define the residual error by these blue lines, this residual errors are the distances between our true points, which are the red points, and our desired price, which is the target, the black line here. So we want these blue lines or these errors to be as low or as small as possible. Hence, we try out various lines and we consider the line with the least error value. Okay, so this is one regression line. We try out another regression line and we consider so many regression lines, and the one with the least residual error is considered to be the best fit line. Again, this is a brief theory on linear regression, and in these examples we looked at only one feature, which is number of bedrooms. In the coming lectures, we'll look at live coding by first looking at a simple linear regression model where we will only consider one feature, for instance number of bedrooms, and we'll compare that to price of a house. And then once we understand that, we'll consider more features. What if we have more than one feature? And we know that the house price depends on many features like number of bedrooms, number of bathrooms, how big is the living space, how big is the lot, where the house is located, whether the house has a basement or not, and so on. So we'll consider more than one feature. We'll consider a few of the features that I mentioned, and we try to build a model and try to predict the price. And we'll compare our two models. So I didn't go into the depths of the math, but if you are interested about the techniques behind the math, you can check out this Wikipedia link, and it has lots of details about the methods used behind the least square method and linear regression in general. Let's go to the wiki link and see it briefly. So here we are at the Wikipedia link that I provided. So it has a method and more description, formulas about the least square estimation technique. You can read more about it here. And here we have some data points in red, and we try to come up with a best fit line for our data points. So feel free to read more of this on the Wikipedia to learn more about the least square method. And also don't forget to check out the scikit-learn's documentation on linear models or linear regression. As I mentioned, linear regression fits a linear model to minimize the residual sum of squares between the observed data points and the predicted line. Just to summarize what we have learned, in linear regression we have certain features and we try to predict a target based on those features by learning those features. In the next lecture we'll look at live coding of linear regression. Thank you everyone.